Lesson 14, evaluating algebraic expressions. Before we start doing this, we have a little bit of vocabulary that we need to discuss. A numerical expression is a combination of numbers and operations, something like 4 plus 3, or 7 plus 2, or even 9 times 2. All we need is some numbers. I guess all we need are some numbers and some operation. So 9 times 2, maybe one more. How about 28 divided by 7? Okay. A variable is a letter used to represent number or a set of numbers. For instance, the d in 2d plus 4, that's the variable. So something like 4x or 7x plus 5. These are expressions that contain variables. Now, we call those variable expressions because, well, like I just said, they're expressions that contain variables. So really, all we have to do to solve those is plug in numbers for the variables and then solve like we normally would. So here's our first example. We have x plus 5, and we're going to solve that when x is 3. Well, everywhere there's an x in this variable equation, we're going to plug in a 3. So x plus 5 becomes 3 plus 5. And then we just simply solve and get an easy 8. Down at the bottom of the page, let's try some examples. We have 9 plus v when v is 2. So we have 9 plus 2. Just plug the 2 in where the v was, and we get an easy 11. Same idea, 9 plus v, but when v is 8, so 9 plus v. But in this case, v is 8, we get an easy 17. When v is 0, we have 9 plus v, but 9 plus 0, just 9. And finally, when v is 1, we have 9 plus v, but v is 1 in this case. So we get a 10. Okay? Let's go to the back page, and I think this right here is supposed to go with the stuff on the next page. So let's get there and make sure. Yep, it is. So x is 2 and y is 8 for our examples up here at the top of the second page. Whoops, I had that backwards. X is 8, y is 2. Okay. X is 8, y is 2. Okay, 10 plus y, but y is 2, so 10 plus 2, that's an easy 12. Y equal y plus 15, but y equal 2, so we have 2 plus 15, or an easy 17. Hey, how about x minus y, but x is 8, and y is 2. 8 minus 2 is an easy 6. Finally, a double substitution again. X plus y plus 11, but x is 11. Oh, I'm sorry, x is 8. Y is 2, and then the 11 from before. 8 plus 2 is 10, plus 11 is an easy 21. Okay, well, sometimes you have to write your own variable expressions. So here's a good example. Let's say you work at the local horse stables, and the manager tells you that some of the horses need new horseshoes, but she's not exactly sure how many horses we're talking about. Write a variable expression to express the number of horseshoes you might need. What we're going to do is we're going to let h be the number of horses. You don't know how many horses, so a variable is ideal in this case. Each horse is going to need 4 horseshoes because they all have 4 legs. So a good variable expression to show the number of horseshoes would be, now, this says 4d. Go ahead and scratch that out and make it say 4h. 4 times the number of horses. So 4h is a good variable expression here. Let's say you're an avid golfer, and you found on average you only lose 2 balls per round of golf. Write a variable expression to show the number of golf balls you'll lose in a typical summer. Well, all it tells us about the number of times we're going to play is a typical summer. We'll know how many times we're going to play in a typical summer. So we're going to use G for our number of golf games. If we lose 2 balls per round of golf, our variable expression would be 2 times the number of games we play. This is our variable expression right here. Finally, let's say we're the manager of a pet store. You plan to separate the 80 fish in a huge tank into smaller tanks. And when you're done, you want to have the same number of fish in each smaller tank. Write an algebraic expression to show how many tanks you would need. Well, you don't know. You don't know how many fish you want to end up with in each tank. So the number of tanks that we're going to use is going to be our variable. So T is going to stand for tanks. We have 80 fish. We don't know how many tanks we can pick from, nor do we know how many fish we want in each tank. We just know that we want the same number of fish in each smaller tank. 80 divided by T, this is our variable expression. Okay, let's go to the third page and finish up with some additional practice on substitutions. Okay, we have XMP, where X is 4, M is 5, P is 2. So let's substitute in. We have 4 times 5 times 2, which is 4 times 5 is 20, times 2 is 40. In the next instance, the next example, here's where things start to get a little tricky. We have the opposite of A minus B minus AB. But look, A is -3 and B is -4. We have to be very careful that when we sub in, we don't lose these negative signs. So here we go, being very careful. This negative sign goes right here. Now A is -3. This whole thing right here that I wrote down represents this right now. Minus sign comes from this right here. Now B. B is -4, being very careful not to lose a negative sign. Minus A times B. Well, A times B. Notice every time I plugged in numbers, I gave them their own set of parentheses so as not to lose anything. Okay, let's concentrate inside these parentheses first out here where the multiplication is taking place. So I'm going to have a negative sign here for minus. -3 times -4, positive 12. But it turns negative again because of this sign right here. 2 negatives in front of the 3, that's a positive 3. 2 negatives in front of the 4, that's a positive 4. 3 plus 4 minus 12 equal -5. Okay, same idea with numbers 3 and 4, and what I would like is for you to try numbers 3 and 4 on your own, and here's where we will start our next class. Remember, if anything in this lesson was confusing or you didn't understand something, make sure you go back and rewatch that section.